Welcome back, deep divers. Ready to explore another hidden world of brilliance in everyday stuff.
Always ready to dive in. What are we uncovering today?
Today, it's something you probably never even think twice about. Getting change at the coffee shop.
Ah, the seemingly mundane transaction. What about it?
Well, behind that simple exchange, there's a pretty clever algorithm at play. It's called a greedy algorithm.
Interesting. I've heard of greedy algorithms, but I never really connected them to something like that.
Yeah, it's one of those things that's so ingrained in our daily lives, we don't even realize the cool math happening behind the scenes. Ever wonder how the cashier always seems to pick the right coins so fast?
Now that you mention it, yeah, they never seem to fumble around or overthink it.
Exactly. So today's deep dive is all about uncovering how this greedy algorithm works, its history, its advantages, and even its limitations. It's going to be fun.
Count me in. I'm always up for a good algorithm adventure.
So let's break it down. What exactly is a greedy algorithm? The name sounds kind of intense, like something out of Wall Street.
Huh, yeah, it does have a bit of a dramatic flair to it. But the concept is surprisingly straightforward. Imagine you're faced with a choice. And at each step, you just go for the option that seems the best right then and there. You're not strategizing 5 steps ahead, just grabbing the most appealing option at that moment.
So kind of like always going for the biggest slice of cake first. I can relate to that strategy.
Precisely. It's all about making the locally optimal choice at each step, hoping that those choices lead to the best overall solution. Hence the name greedy. It's always going for what seems best in the immediate moment.
This all seems to make sense so far. Are there times when always going for the biggest option first doesn't actually give you the best result?
That's a great question, and it gets right to the heart of why greedy algorithms are so interesting. While they often lead to good solutions, they don't actually guarantee the absolute best outcome in every situation. Sometimes that grab the biggest slice mentality can actually backfire.
Okay, now I'm really intrigued. Let's go back to that coffee shop scenario. Say I hand the cashier a $10 bill for a latte that costs 4.50. Walk me through how they'd use this greedy algorithm to figure out my change.
Sure. So they need to give you back 5.50. Following the greedy approach, they start with the largest denomination that doesn't exceed that amount, which would be a $5 bill.
All right, so we've used the biggest bill first. What happens next when we have smaller amounts left over? How does the greedy algorithm handle that?
They continue aiming for the largest possible option at each step. Now they have 50 cents left to give you, so they go for the largest coin, a quarter, or 25 cents. Then another quarter, and boom, change made using the fewest coins possible.
Wow, I never realized there was such a calculated method behind something so seemingly automatic. Pretty cool.
It is. And what's even more fascinating is that this idea isn't exactly new. You might be surprised to learn that the roots of the greedy algorithm go way back. We're talking ancient
It's
Greece.
easily like togas and the Parthenon ancient.
Yep, that ancient. Mathematicians like Euclid used principles that resemble the greedy approach in their work. One example is Euclid's algorithm for finding the greatest common divisor of two numbers, a classic example of a greedy algorithm in action. So this concept has been around for centuries.
Wow, I never realized something as old as Greek geometry could connect to modern algorithms. That's pretty amazing.
It is. It shows how fundamental these ideas are. But to answer your earlier question, the formalization of the greedy algorithm as a distinct problem-solving strategy came about much later in the mid-20th century with the rise of computer science.
Ah, so that's when it really took off.
Exactly. It became a key tool in computer science, especially for tackling what we call combinatorial optimization problems.
Combinatorial optimization problems. Okay, that sounds a bit complicated. Break that down for me.
Okay, so imagine you have a bunch of different tasks to do, and you need to figure out the best order to do them in to finish as quickly as possible. That's a combinatorial optimization problem. Essentially, you have a finite set of options and need to find the best combination.
So like figuring out the most efficient route for deliveries or something.
Exactly. Or, as we've seen, making change efficiently. It's all about finding the best arrangement or combination out of many possibilities.
So the coin change problem is a perfect example of where these greedy algorithms really shine.
Absolutely. It's a classic application. To define it formally, the coin change problem asks, given a set of coin denominations and a specific amount of money, what's the smallest number of coins needed to make up that exact amount?
Okay, I think I'm following so far.
Right.
But let's make this a bit more challenging. What if I needed to get 3.87 yuan in change? How would that work?
Okay, so let's say we have coins and denominations of 1 yuan, 50 fen, 25 fen, 10 fen, and 1 fen. Following our greedy algorithm, we'd first grab three 1 yuan coins.
All right, that leaves 87 fen, right? What's the next step?
Exactly. We'd then use a 50 fen coin, bringing the remaining amount down to 37 fen.
Right.
Then we'd grab a 25 fen coin, leaving us with 12 fen to go.
So far, so good. It seems like this greedy approach is working out pretty smoothly.
Right. And to finish up, we'd take a 10 fen coin and two 1 fen coins to make the remaining 2 fen. So in total, we used 8 coins to make change for 3.87 yuan.
Makes sense. It's efficient, easy to understand, and it seems like even I could do it. What's not to love about the greedy approach?
Well, as we hinted at earlier, it's not always a foolproof strategy. Remember how we said that choosing the biggest option first doesn't always lead to the absolute best outcome? Let's look at an example where the greedy algorithm stumbles a bit.
Okay, I'm ready for this plot twist. Lay it on me.
Imagine a coin system with 1 cent, 15 cent, and 25-cent coins. You need to make change for 30 cents. If you follow the greedy algorithm, what would you do?
Well, I'd grab the biggest coin first, the 25-cent piece. That leaves me with 5 cents to go.
And you'd have to use 5 1-cent coins to make up the difference for a total of 6 coins.
Hold on. There's a better way, isn't there? I could use two 15-cent coins and get to 30 cents with only 2 coins. So in this case, the greedy algorithm didn't actually give us the most efficient solution.
You got it. This highlights one of the limitations of the greedy approach. It focuses on making the best local choice at each step without considering the bigger picture. Sometimes, a different strategy that explores more possibilities might lead to a more optimal outcome.
That's really interesting. It seems counterintuitive that picking the biggest option wouldn't always be the best strategy. Why does that happen?
It's because the greedy algorithm doesn't look ahead or backtrack. It makes decisions based on the current state and doesn't consider the potential consequences of those choices down the line. In that 30-cent example, if the algorithm considered the possibility of using two 15-cent coins, it would found a more efficient solution. But because it's so focused on that immediate biggest choice, it misses that opportunity.
So if greedy algorithms aren't always perfect, why are they so widely used?
It often comes down to practicality and efficiency. Greedy algorithms are usually very easy to implement and understand. They can provide solutions quickly, especially for large-scale problems. And in many cases, the solution provided by a greedy algorithm is good enough, even if it's not the absolute best. Plus, in some systems, like the US coin system, the greedy algorithm actually does consistently find the optimal solution.
So it's a trade-off then between finding the absolute best solution and finding a good solution quickly.
Exactly. And the choice of which approach to use depends on the specific problem and the constraints involved.
This is getting really interesting, and to think all this complexity is hidden behind something as simple as making change. It's like there's this whole secret world of algorithms operating behind the scenes of our everyday lives.
It really is. It's a testament to the power of these simple yet elegant problem-solving strategies. And the coin change problem is just one example. Greedy algorithms have a wide range of applications in various fields.
Like what? What are some other examples of greedy algorithms in action?
Well, let's think about GPS navigation. When you use your GPS to find the shortest route to a destination, it often uses a greedy algorithm. It might choose the road that appears shortest at each intersection without necessarily considering the overall traffic conditions or potential delays further down the route.
So it's making the best local choice at each turn, even if that might not lead to the fastest arrival time.
Precisely. And there are tons of other examples too. Think about how you pack a suitcase. Do you try to fit the biggest items in first? Or how about choosing the shortest line at the grocery store? These are all situations where we often use a greedy approach to make decisions.
Wow, I'm starting to see them everywhere now. It's like a whole new way of looking at the world.
That's the beauty of understanding these concepts. It opens up a new perspective on how things work and how we approach problem solving in our own lives.
You know, it reminds me of that famous Richard Feynman quote, "Nature uses only the longest threads to weave her patterns, so each small piece of her fabric reveals the organization of the entire tapestry." It's like, even in something as mundane as getting change or packing a suitcase, there's this elegant mathematical tapestry at play.
That's a beautiful way to put it. And it speaks to the broader takeaway here. The greedy approach isn't just a tool for computer scientists, it's a way of thinking.
So it's about trusting your gut in a way, like sometimes the simplest solution is the best one.
It's not entirely about trusting your gut, but more about recognizing that simplicity can be a powerful force. In many cases, the greedy approach provides a practical and efficient path forward, even if it doesn't always lead to the absolute mathematically perfect solution.
This whole deep dive has really changed how I view everyday things.
Yeah.
I'll never look at making change or using my GPS the same way again.
That's the beauty of exploring these hidden algorithms. They're everywhere, influencing our lives in subtle yet profound ways. And the more we understand them, the more we appreciate the intricate workings of the world around us.
So where else might we encounter these greedy algorithms in our daily lives? Any hints you can give our listeners?
Hmm. Well, think about how online retailers recommend products to you, or how social media platforms curate your newsfeed. These systems often use greedy algorithms to personalize your experience based on your past behavior and preferences. They're constantly making decisions about what to show you next, aiming to keep you engaged and coming back for more.
It's like they're trying to predict what we want before we even know it ourselves.
Exactly. And that's just the tip of the iceberg. Greedy algorithms are used in finance, healthcare, logistics, and countless other industries. They're all around us, shaping our experiences in ways we may not even realize.
This deep dive has really opened my eyes to the hidden world of algorithms. But before we wrap up, I have one more question. Are there other types of algorithms that are similar to greedy algorithms, or is that pretty much the main approach for solving these kinds of problems?
That's a great question, and it leads to an important point. Greedy algorithms are just one type of algorithm within a much larger family of optimization algorithms. There are many other approaches, each with its own strengths and weaknesses.
Oh, so what are some of those other approaches? Give me a sneak peek.
Well, there's dynamic programming, for one. It's pretty cool, actually. It breaks down these big, complex problems into smaller, overlapping subproblems and then, combines the solutions to those subproblems to get to the overall optimal solution.
Okay, so it's a divide and conquer strategy, but smarter.
Exactly.
Yeah.
It's a bit more computationally intensive than the greedy approach, but the cool thing is it can guarantee the absolute best outcome in certain scenarios.
So it's more thorough, but maybe not as speedy.
Right. It's a trade-off, like we were talking about earlier.
Okay, what other approaches are out there?
Well, there are also things like branch and bound algorithms. They basically systematically explore the possible solution space, eliminating branches that are guaranteed to lead to suboptimal results.
So it's kind of like a more intelligent search process that avoids wasting time on dead ends.
Exactly. This approach can be really effective for problems with a relatively small search space where you don't have to explore a ton of possibilities.
Makes sense. Anything else?
Oh yeah, there's a whole bunch. There are even more specialized algorithms for specific types of problems, like genetic algorithms, simulated annealing, and ant colony optimization. It's a whole fascinating world out there, really.
Wow, this deep dive has really sparked my curiosity about the world of algorithms. There's so much more to it than I ever realized. But I think we've given our listeners plenty to think about today.
Definitely. Hopefully they've come away with a new appreciation for these hidden algorithms that are shaping our experiences all the time.
I know I have. Before we sign off, any final thoughts you want to leave our listeners with?
Yeah, I just encourage everyone to keep an eye out for these clever problem-solving strategies in action. Start paying attention to the choices you make, the systems you interact with, and see if you can spot those telltale signs of different algorithmic approaches at work.
Ooh, that's a good challenge.
You might be surprised by what you discover. And who knows, maybe you'll even find yourself applying some of these concepts to your own life.
I love that. So as you go about your day today, remember that seemingly simple act of getting change at the coffee shop and the elegant, greedy algorithm that often guides it. And keep in mind that there's a whole universe of other algorithms out there, silently shaping our experiences in fascinating ways. Until next time, happy deep diving.